transform. Where's the transform? There it is. Am I really quiet? Yeah, because my microphone's all the way over there. Testing, testing, testing. So, as some of the more astute of you have noted, I missed the memo. Oh my goodness. No, come on, come on. Work with me, computer. There we go. There we go. No. Come on. That's still too wide. What the heck is going on? $100 and 20, 30, 40, 50, 60, 70, 60, 70, 70. Very slimming look. 80. 90. There, that'll do. Alright. Hello, everybody. So, I currently have 22 people watching right now. Welcome to Nick Just Plays with the webcam for an hour. Yes. Well, I was actually playing with OBS. The webcam is a completely different piece of technology. So, am I, like, very quiet? Alright. There we go. So, McMaster Daily Newsed. McMaster has daily newsed me. McMaster closed on Monday, January 17th, due to inclement weather. Let me tell you, it was a lot more than inclement weather. Inclement just means there's going to be bad weather, but we definitely had bad weather by the time that this decision was made, I think. Unless it was made yesterday. Nope, it was made today. There you go. So, McMaster is closed on Monday, January 17th due to a significant winter storm hitting Hamilton and much of southern Ontario. By the way, be glad you don't live on Welland if you don't live in Welland, because Welland got 3 feet of snow. 3 feet. That's like half my height. It's crazy. So, all scheduled classes, labs, studios, and events in person and, crucially, remotely, are canceled. Now, I can't think of any good reason why a remote class would have to be canceled. Yeah, okay. I'm gonna try turning up the gain a little bit on this. Tut 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 tut. Law! Okay. I'm not in the red zone, so that should be okay. I can't think of any good reason why remote classes would need to be canceled, but here we are. And I'm here, and I put on my bow tie, so, you know. Yeah. Mark says, my front door is blocked by snow. It's great. Yeah. Welcome to Mac and their weird policies. Oh, you don't have to tell me. You do not have to tell me. I guess given that I can't really cover any new material today because this class is technically not supposed to even be happening, I guess, oh, people may have experienced power outages? Oh, possibly. Possibly. Profs are doing a snow fight. Yeah, possibly. Quite possibly. So I guess we'll just make it a Q&A then. I live in residence and the power went out. I'm connected from a hotspot. Wi-Fi is still off. Huh. Well, you know, don't suffer any data overage charges on my account, please. But yeah, if anybody wants to ask me a question about the course or any of the material or anything like that, I would be happy to chat with you guys for you know, a certain amount of time. And if you know, if nobody has any questions at all, then I guess we can all get on with our days, and I can finish shoveling. I just have a little bit left to do. The neighbor was very kind and brought round his snow blower. If anyone wants, we could play Jackbox party games. I have all but 8. I don't know how that would work. Yeah. Well, I know people like my class, you know. Generally speaking, people like my class. What will we cover in tutorials this week? So this will be the first week of tutorials. So, generally speaking, there are, like, getting you online with the software that you need is, like, priority numero uno. But, aside from that, just a small programming example. I could make a Discord voice chat and share my screen. Coding bat, yeah. There are 2 cars stuck on the main road right in front of my house. They gave up. They just gave up and left the cars on the road and walked home. Oof. Where are you? Where, like, what, are you down by the university, Sarth? It's kind of funny. There's this thing called, lake effect snow. Those of you who may be new to Ontario may not know what lake effect snow is, but here's a little bit of an education in microclimates. So you have the Great Lakes, right? Mississauga. Yeah, I can see that. So this is why Ontario gets a lot of snow, because, like, in general, you know, Ontario doesn't, like normally, Ontario doesn't get a lot of snow. But every once in a while you get a big snowstorm like this. And one of the reasons you get big snowstorms is an effect called lake effect snow. So the Great Lakes are these gigantic bodies of water. Like, they're the largest inland lakes in the world, I believe. Except for maybe one in Russia, which might be bigger, I think. And possibly one in the Northwest Territories. But anyway, they're among the biggest lakes in the world. And because they're made of water, they're also enormous heat sinks. So they collect heat throughout the entirety of the summer. And in Ontario, you know, you can get like consistent 30-degree Celsius days in the summer as well. Ottawa is the national capital with the highest temperature swing of any country in the world, actually, because you go all the way from 30, 35 in the summer all the way down to negative 25, 30 in the winter. But yeah, so the lakes have all of this heat energy, and about this time of year, they're still providing a fair amount of heat into the sort of local area, particularly areas that are on the coasts of the lakes. So that's actually why the Golden Horseshoe area is sometimes called the Banana Belt, because it's warm enough here to grow fruit trees, which normally you can't get good fruit. Like, you need reasonably decently warm weather to grow fruit trees, and you don't usually get that this far north. But because of the lake effect, the effect of the lake in warming the area in the winter, you can grow fruit here. But anyway, so these lakes have all of this heat energy, right? And during the winter, this heat energy is coming off of the lakes in the form of water vapor still. And basically, all it takes is for the wind to be cold enough and in the right direction and going fast enough that the the vapor that's rising off of the lakes, which are still reasonably warm from the summer, is condensing into snow in the upper atmosphere and then dumping immediately on the coastal areas around the Great Lakes. We don't usually get it this side of Ontario. Normally, places like Barrie and Sarnia, which are on the more westerly side of the Ontario Peninsula, these are yeah, they get hit with the lake effect snow a lot, but just because of the particular manner in which the wind is blowing in this storm, basically Welland, the Niagara Peninsula, got a huge dump, and we all got a decent bout of it as well. So, but yeah, anyway, yeah, I know that's not about computer science, but nobody's asking me about computer science, so you know. If it's okay, Mark, I think I'd like to not do that. Just like putting a stream through like two different things seems terrible, like a terrible idea. Do you think you could do out the parrot trouble question and warm up one of Coding Bat live? The solution was a bit confusing to me, and I was curious if you would have a different solution. Oh yeah, sure, I can do that. I just like to check with the TAs that they're not like planning on covering it in tutorial. Because if they will, I'll just let them, you know, I don't want to steal their thunder. Coding Bat Python. Warm up one. The parrot trouble. All right. It's actually being covered in tutorial tomorrow. Okay, what's one that you guys aren't covering then? Yeah. I mean, you guys are welcome to. I'm sure you could set it up with the Discord. But, do we have access to Jupyter through the command prompt for Anaconda, or is it fine if we just use the link on Avenue? So there's a distinction between the online sort of browser-based version that you access through the link and a local installation of Jupyter. So in either event, Jupyter is going to have to be running inside of a web browser. But when you have launched Jupyter from Anaconda, what your computer is actually doing is it's kind of generating its own server internally, which it's referring to, rather than the server that we have set up for you. So so yeah, you won't be able to fetch the assignments from the JHub server if you have installed, or if you're running it from a local installation. You have to go through Avenue to actually get the assignment file. Yep. So you guys are doing parrot trouble. Right. There were no tutorials last week. Yeah. Okay, so let's try makes 10. Why not? Or chance. Diff 21. Given an integer n, return the absolute difference between n and 21. Except return double the absolute difference if n is over 21. Well, that's easy enough. So, so we have n. So, difference will be 21 minus n. The absolute difference, if, so, like, there are two ways of going about doing absolute value. One is to just use abs, which is the fastest and easiest way to do it. But, of course, what the absolute value function is actually doing is if diff is less than 0, diff equals diff times -1. There you go. Now, return double the absolute value if n is over 21. So, if n is greater than 21, return 2 times the difference. Otherwise, pardon me, return difference. Let's see how I did. Yes, I know you can do it in one line, Mark. Thank you. Go. Okay, 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 okay. All correct. That's really small and difficult to see, though. Let me see if I can blow it up a little bit. There we go. Ta-da. So, let's do another one. Not string. Given a string, return a new string where not has been added to the front. However, if the string already begins with not, return the string unchanged. So, there we go. So, crucially, and this is a very important thing to note with these types of string questions, always pay attention to the white space, right? So if you take a look here, there's actually a white space character. There's a space character right there at the end of not, right? So it's very, very important to make note of that. Lots of people sort of think that space is just nothing, but in a computer it's very crucial. Like, it's an actual character, just like the N, the O, and the T. So oh, that is how I would think when writing this program. I was wondering, though, how one goes from writing many lines to just one line. Well, it's really just experience. I would recommend at this point, like, unless you're you have some experience with coding, don't worry about cramming everything into one line and being fancy like Mark. Not that it isn't cool to be fancy, but you know, it just, one of the things that's really, really important when you're doing an algorithm is to break it down into small, manageable steps, and then be able to put those small, manageable steps together to form the algorithm, right? So what Mark is doing here by making the solution all in one line is what his brain is doing is it's undertaking a large number of steps all in one line because he knows how to concatenate. He knows now how to put them all together. But if you're new to coding, I highly recommend making each of your individual lines as simple as possible. But yeah. Yeah. As Sarth notes, this course doesn't really require you to get in one line. Yeah, I would say it definitely doesn't require you. There's actually no benefit to reducing line count. It can actually be worse for performance and readability. Code it in a series of logical, English-like steps, a paragraph rather than a sentence. I would say yes, but don't make this mistake of thinking that there's any analogy between coding and English. I sometimes see people who, like, are coding like they're writing a sentence in English, and because, like, there's, like, there's a number of English words are being used in programming, and sometimes I've seen people who, like, are using, like, the word while as if it was embedded in a sentence and was subject to English grammar. It really isn't. You should think of while as being a mathematical construct. But, similar to a plus sign. It is more of a plus sign than it is a conjunction. Let's put it that way. Python and English are both messes. Yes, that's true. In particular, the way that there's no, like, English pronunciation is, like, the worst, probably, of any language I've ever seen. So there are multiple methods to solve a program, not just one way. Oh, yes. Oh, yes. Like, 100,000% yes. It's actually kind of interesting. The longer the piece of code is that you're working on, the more likely it is that you'll come up with a solution that's absolutely unique to you. It's like, think about it this way, right? You wouldn't necessarily expect any two people to write the same sentence, even if it were on the same subject matter, right? And still less, you wouldn't expect two people to write the same paragraph, even if it was on the same subject matter. The same property holds for programs. If two coders are working on the same problem, it's very likely they'll come up with completely different solutions to it. Which is kind of fun, There is absolutely not just one way to code things. In this class, I kind of take the philosophy that I'm not going to teach you a lot of stylistic points unless they're, like, common pitfalls, right? The approach that I take with teaching people coding, generally speaking, is, like, you should be given the freedom to be able to find your own style of coding. Because it's only by finding your own style of coding that you will actually understand the concepts that you're using. I thought we aren't comparing English to Python. Shut up. Listen, Sarth, I've had just about enough of you. But, yeah, so, I sometimes bring in this actually, I frequently bring in an analogy to Kung Fu and martial arts in general. They say that there are 10,000 students, but 3 masters. So, as a beginner, you'll have, like, a very different way of going about solving these problems than basically, the more experience you have, the more you start to sort of snap off the extra bits that you don't need, right? It's like, as you gain experience with coding, your style will become streamlined, and you'll be able to do less and more and more with less and less, right? Just because, like, you're focusing in on just those pieces that you actually need to solve the problem. What's in the mug today? It's orange Picot tea. Again, it's my favorite tea. So as you become more experienced, your coding style will begin to resemble other people's coding style to some extent, but it's not completely perfect. So yeah, how many ways are there to solve every single programming problem we give you in this course? Maybe 10, 100,000? Literally, actually. Like, combinatorially speaking, probably more than that. So anyway, this problem. Return a new string where not has been added to the front. However, if it already begins with not, return the string unchanged. So the big thing here is this, this split. This is the decision that needs to be made. We need to know whether or not the thing already begins with the word not. Now, this kind of dips into stuff that we haven't covered yet, but I'll show you how to do it anyway. So, if so, interesting, right? Crucially, the test condition does not care about the space, right? So, if string, I'm going to do it several ways. If string 0 equals n, and string at 1 equals O, and string at 2 equals T, return just the string. Otherwise, we return, and this is kind of fun that you can do this in Python, just not plus the string. Plus, when you apply it to a string, is what's called concatenation. So that just smushes the two strings together. Yes, thank you, Mark. Let's see if this works. Compile problems. Uh-oh. String index out of range. If string at length of string is greater than 3, actually, I can just pop that down there. So, the problem that I ran into here is, what if you test this on a string that doesn't have anything in it, right? We need a string with minimally 3 characters in it to see if to be able to even perform this comparison. So I have layered in a secondary comparison to see if the string is of that length. Yeah. Everyone would be jealous of my tea selection. Yeah. Oh, David's tea subscription. My goodness. Yeah. If it wasn't for coffee, I would have dropped out of Unity by now. Yeah, really. Yeah, I like coffee. I like some coffee. I prefer Italian coffee, to be honest with you. There's a case missing from this code now, specifically more than 3 characters, but not starting with not. Let me think about that. So, if less than 3... So, greater than 3... Oh, yeah, you're right. I'll just remove the else case. Good. Thank you, Mark. So, let's see. Running code. Aha! So this, I think, is a problem with the specification, to be honest with you. It is expecting not to be prepended. So that I would say this is a problem with the, yeah. Wouldn't this not work for the X test case? No, it works for X. Let me pull up, yeah. So, yeah, so essentially, the assumption that's one of the assumptions that's built in here, if the string is less than 3, then it can't possibly have not at the beginning of it because it's too short. So it will never make this condition where we just return it. So we're always going to have to put not at the beginning of it. However, they tricked me. And I would say that the lack of a space here means that the question is wrong. So if you put not in, they expect you to get not out with a space in between. If you highlight it, you can see that there's a space there. That's a clever programmer trick, by the way, is if you you can see invisible white space by highlighting if it's at the end of a line. So what we can do is we can add one more case, and string 3 is equal to not, or just the space, pardon me, there we go, and go, and it still doesn't work. Really? Why doesn't it? Let me pull this into something I can actually work on it in. So, Python tutor. I kind of like this class. It's kind of chill, you know? So, and then I want to try it on not string not. Let's see what's going on here. Keep hitting Control S. Jeez. All right. So we got not. There we go. Return not plus string. Return value not. So how is that bad? How is that different? The return expected is on the left box. You're returning not, but it wants not. Oh, really? Oh, I see it. Right. Okay, yeah. Okay, I got it. So I was correct before. I just needed to do that. Maybe? Let's see. There we go. Pardon me, folks. So, kids are so much fun. So yeah, there you go. So I had an off by 1 error, which is a pretty common type of error. So let me show you a way of making this a little bit more compact, because this is kind of a pain in the butt, you know? You can imagine if you were trying to match more characters than this, it would get, like, really tedious, right? And you don't have to do it this way. What you can do is you can say, from 0 to 3 minus 1, this is a string slicing operation, that is equal to not. And this has the same effect. So, slicing operations are kind of cool. Python 3, there we go. So if we have a string, like hello world, you can get the first bit of it. Actually, the 0. No, yeah, the 0. You can get you can take the 0 out as well, and it still works. So you can get from the beginning to some specified, one less than some specified index, that way. Oh, let's, there we go. You can get from some specified index to the end by going the other way around, like putting the index on the other side of colon. Could you explain why we didn't use else again? Sure, I can. So, so essentially, the reason that we don't want an else case here is we sort of have a code formation where we want a catch-all case at the end, right? So, regardless, like, basically, it has to do with what return does, right? So, what a return statement does is it terminates the function when it is reached. So once the code reaches, or once the program's execution reaches any return statement, that function is kaputski. It is finished. It doesn't execute anything else in that piece of code. So there's no possibility, if both of these conditions come out true, that the code will progress any further. So by either of these two conditions not coming out true, we'll end up here anyway. But we won't if they're both true. So we can just put this here. Now it's not absolutely necessary that you do that way. If you combine these two conditions into one, you can say return string, else return not string. That will have the same effect. You can see all of our cases are still passed. And actually, once you have it in this formation, there's just one more small adjustment that you need to make to get it into single line format, as Mark was saying. I'm going to put it in a comment. Basically, return string if this condition, else not plus string. You can take these if-then-elses and compose them into one line using infix notation, and you can see it all comes out as well. But, this is more difficult to read, which is why I don't recommend that beginners attempt things that way. But yeah. Let's see here. Yeah. I remember you saying that the first class, that the coders on Chegg are not great coders. What constitutes as a bad coder? Oh, let's see what Mark has to say. Maybe I'll have some other stuff to add. Ignoring details of the question to make the solution that doesn't do what the question asks. Yeah, so they'll misunderstand the question that's being asked. That's a big one. So, while there are 10,000 correct answers to any coding problem, there are literally an infinite number of wrong answers, right? So if any two people get the same wrong answer, that's like, you cheated. You cheated, They also tend to make code that is absurdly long with odd variable name choices. Yeah. In an if block is... Yeah, good. Chegg answers we see are just wrong. The issue is if you go from failing a single question to an entire tester assignment repeating. Yep. I just found out when you do string 3, even if a string is less than 3 characters, it still works. Ha! So I could technically remove this condition. Okay, there you go. Yeah, there you go. So, that simplifies the solution even further. Is len actually a function in Python? Yes, so len is a very, very useful one, actually. All it does is it returns to you the number of elements in a data structure. There we go. So, hello world with an exclamation mark has 12. If I have some list, which I know we haven't covered yet, but, whatever. The length of L is 6. So, even if you get, some of the more exotic data types, like dictionaries and sets, which we'll be covering in due course, length works on them as well. So it's not even just, the length, which is sort of implicitly sort of semantically applies to linearized data structures. For data structures that aren't necessarily in linear order, it becomes a test of cardinality. So, like, you can actually have sets in Python. Set from set theory. Sets are not allowed to have duplicate elements. You can't index a set. So S at 2 doesn't make any sense, because it's a set. However, you can still take the length of it. Length, basically, as applied to set, tests for the cardinality of the set. And I don't know, you guys know discrete math at all? I don't know how much discrete math, I don't know how much set theory they do with you guys in high school anymore. The only thing PHP did well, in my opinion, is renaming this function to size or size of. I also kind of like count. Yeah, I'd say so. When it calculated the length of Hello World, did it include the space? Well, yes, it did. If we take a look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Bing, bang, boom. And it came out with a length of 12. Space is totally a character, yeah. It is a character with an ordinal value of 32. We're gonna get into it. Like, I'm kind of going into stuff that we haven't really at all covered yet, because we've only really gotten as far as, like, if statements and while loops. So, you know, take this as you will, but yeah. And thank you everybody for, like, sticking around, because, like, you're really not obligated to be here. And, you know, it's, I don't know. I feel like we can get some learning in, you know? Hopefully this is useful to people. Yeah, okay. So, let's see. Given two integers a and b, return true if one of them is 10 or if their sum is 10. Okay. This one's also let's see. Mark just sent me this as a link. Space. Yeah. So this one's fairly easy as well. These are all easy. That's why they're the the easy warm-up section. But so essentially, we've got two conditions we want to test, right? We want to test if one of these things is 10, and if they sum to 10, right? So that's actually technically three conditions, because A can be 10, B can be 10, or the sum of A and B could be 10, right? So let's do this like as simply as possible. If A is equal to 10, return true. If B is equal to 10, return true. If A plus B is equal to 10, return true. And if you get through all of that without having returned true, return false. Boink. And you can see that is a big gold star, because I got it on the first try. First try. So this is kind of a long solution. So I'll show you how to make this a little bit simpler. They're not easy for me. Yeah, I know, but, you know, that's the whole point of practicing, you know? Hopefully, by the end of this course, you'll look at a problem like this, and you'll be like, oh man, did I ever have it easy. So, so you can do a couple of things here. You can, like, for one thing, we might observe that each one of these return statements returns the same thing, so we can compose them. So, if a equals 10 and b equals, or b equals 10, or a plus b is equal to 10, then return true. Else, return false. Boop. Yeah. Is the double equal sign just Python syntax? That is an excellent question, Daniel. So, the double equal sign is a test for equality, as distinguished from assignment. So if I had some, let's say I had some third variable, c, which I'm setting to false. This is another way that you can do this sort of question. C is equal to true, and in either event, we return C. You can see, so to speak, that this also is a correct solution, right? So what we're essentially doing here is we're taking a variable, storing false in it, and if this, like, if any of these conditions are true, we set C to true, otherwise it will still be false, and when we return at the end of this function, that's just, you know, if this didn't activate, then it's still false, so we get the correct answer, and if it did activate, it activated because one of these conditions is true, so we get the correct answer. But note the difference here, right? Double equal sign is a test for equality. So we're saying if a is equal to 10, right, is equal to. In this case, we are setting the value of c to true. So you interpret this symbol, true is assigned to c, or c is assigned true. So they have very, 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 very different purposes, right? So it's crucial that you learn the difference between the two, basically. Good. So why didn't we use else the first time? Because we don't necessarily need to. Like, another way that you might be able to formulate this is else c is equal to false. So, you know, and, you know, I could, if I wanted to, I could make this a one-liner as well. Return true if... Well, actually, I can... I'll show you this way, and then I'll show you something even... something even more compact. So, true if this condition, else false, right? So that's the simplified version. But we can also use the observation that this returns a Boolean to do the following, right? We can just say, return the evaluated result of the condition, which is kind of cool. And I just want to show you guys that that one works, because that might blow your... that might bake your noodle a little bit. See? That works. So, to some extent, like, it's kind of useless to, like, explicitly return true in the true case and false in the false case, because, you know, the evaluated result of the condition itself will be, you know, true and false if it's true or false, you know, so you can just use it directly, actually. But that doesn't answer your question. Why didn't we use a else case in the first case? Well, I was trying to demonstrate like a useful way of thinking about code. It's often useful to think about, I set up some value. If something happens, it changes. And in either event, I want to return it at the end. Later on in the slides, we'll see that it's actually very useful to restrict where you put the return statement. Like, generally speaking, when we code, we want to avoid a condition known in programming as spaghetti code. Spaghetti code happens when it's not easy to predict the path that a piece of code will take, because you have like inputs coming in weird places, outputs going in weird places, and everything just kind of spins together into this jumbled mess. The way that you avoid that is by explicitly having things enter at the top and leave at the bottom, and always try to stick to that, right? Let's put it this way. Multiple return statements within one function is mildly discouraged. The reason I say mildly discouraged is because I have certainly been guilty of using multiple return statements myself. I consider it a stylistic point. I'm not sure it's useful at this level to, like, you know, mark you down for doing something like that, you know? Like, I would never dock you marks for using multiple return statements in one function. Just know that it's like a stylistic point that makes your code slightly harder to read and use. But, you know, if you've struggled with a problem for 3 hours and your solution that works has multiple return statements in it, I want you to submit that solution regardless as to whether or not it's stylistically correct. Like, generally speaking, I'm not looking for stylistic correctness from you guys. I'm looking for you guys to write programs that work. The functionality comes prior to the form, right? So, and that's how your assignments are going to be graded. They're going to be graded based on, does your code work? Period. Doesn't matter if you take a simple algorithm like this and take 50 lines to do it. If those 50 lines are correct, you get the marks. You know, that being said, I would say 50 lines of code are 50 lines of code that have the potential to have bugs in them, right? So, like, you can reduce the number of possible bugs in your code by reducing the size of the code. Like, you know, the longer the code, the more things can go wrong with it, basically. So, like, there are reasons to try to trim your code and keep it small. But, like, at this level, that's very much a secondary consideration to you just getting the code working correctly, right? Because that's what intro class means to me, basically. Is like, you guys need to have the stylistic freedom to be able to learn how the code actually works, because you need to be able to explore it. But, yeah, okay, so not bad for a class that we weren't even supposed to have, eh? Are there any further questions? In the assignment, if our program passes all the tests in the assignment, is our program 100% correct, or could it still be wrong? So, that's a very good question, Richard. Thank you. Thank you for that question. So, So the test cases that you are presented, which are visible, are different from the test cases we use to grade. And there's a very good and important reason for that. The test cases that are visible to you, it's very, very easy to write an algorithm which passes just the visible test cases. Like, you'll notice they give you a few here, but, you know, they then have a whole bunch more that they test you on that they didn't give you up here, right? It is easy as pie, once you get going a little bit, to be able to write an algorithm that just covers these cases, right? So this, whether, like, the fact that you have hit these test cases is kind of immaterial to whether or not you've actually written the algorithm. Like, I'll give you an example, right? So I'm not even going to read the question. I'm just looking at test cases, right? So if A equals 1 and B equals -1 and negative equals false, return true. If A equals -1 and B equals 1 and negative equals, I need 2 equal signs there, false, return true. And if A equals -4 and B equals -5 and negative equals true, return true. Go. You can see I've hit the first 3 test cases, but I've hit none of the other ones, right? And that's actually because I'm not returning anything. I could probably do pretty well by just assuming that otherwise you want false, and let's see how well I do. Yeah, actually, so I've hit a lot of test cases with that. But you can see that there are test cases certainly that I haven't hit. So, and I didn't pretend to not read the question. I actually didn't even read the question here. I'm just reconstructing the answer from the test cases, right? So, so you can do that with any question, with any test cases, right? It doesn't matter what the question is. So we require you to actually implement the algorithm as described in the question, which means that the test cases that you're actually going to be graded on are not going to be visible to you when you perform the assignment. Now, if you have if you've done a solution that's better than this one, right, and you have gotten all of the visible test cases, you're probably gonna get, you know, I'd say probably at least a 70% on that question. Sometimes we test little edge cases and little gotchas to see if your code is actually good, or if it borks up on, this input or that input. We're kind of testing your code for a little bit of robustness as well. And I just want to say that 70% or like 75%, B range means you're meeting expectations, right? A range means you're exceeding expectations. So, if you're getting 70s, that means that you're actually like meeting my expectations for you in this class. So yeah, I guess the long answer, the short answer to your question is no. If you pass all of the visible test cases, that does not guarantee that you're going to get 100% on the question. But the test cases are designed so that if you get all of the visible test cases and you've actually done the question and you haven't come up with a BS answer like this, you will get, certainly, like, you should get most of the marks there, unless you've made, like, some, compilation error. We have no mercy for syntax errors. If you're going to submit code, If it doesn't run, it's not worth anything. Zip, 0. It must run and compile in order to even be possibly worth anything. So yeah, so that's sort of the long answer, but does that make sense? Hopefully that makes sense. Like, I can do this again, you know? I could even do this on, like, on a more difficult question, but... Oh, that's monkey trouble. Yeah. Near 100. If n is equal to 93, return true. If n is equal to 90, return true. If n is equal to 89, return false. And then, just a lucky guess, maybe, return false if none of that worked. Let's see how I did. Pretty good, actually. Like, depressingly good. But, you know, these are very simple problems, and this, like, that method, like, just guessing here, that works, like, here, you got a 50% chance, right? Because it's a true-false answer coming out of this function. But if it's an integer, you're not gonna, like, your chance of guessing the correct answer is, like, very, very low. And you can see that I didn't even read the question, and I'm already, like, I did reasonably well hitting these, you know? Love how my tea is finished at the same time of the lecture. Yeah. Yeah, it's, you know, it's pretty good. Pretty good. Anyway, so I guess that's everything. Thank you everybody for sticking around. This was, you know, I hope you guys found this useful. I hope you guys got some of your questions answered, but, yeah, enjoy the rest of your snow day, and, I'll be seeing you. Ciao.